All right. Hopefully I'm the person giving this lesson tomorrow, Thursday, February 6th, in as opposed to you watching a recorded lesson, but I am still not feeling the best. Um, the stomach flu or whatever is really taking it out of me. So I'm going to do this as a backup. So yesterday you guys did a review of graphing lines. The reason for that is that we are going to be looking at solving systems of equations today by graphing. So we have a explore and reason. Please follow along on your notes. And we should be good. So here we have Juan and Leo were supposed to meet and drive ATVs together. I don't know why it says drive ATVs on a train, but they're not driving on a train, on a trail. Oh, that should be on a trail. Nice typo. Okay, my bad. Supposed to drive ATVs on a trail together. I need to fix that because that's going to bug me. Trail. Juan is late, so Leo started without him. Juan is late, and there's Leo. All right, so we are supposed to write an equation for Leo's distance from the starting point P after writing for X hours. So Leo's distance. Distance is rate times time, just in general. Distance is equal to the speed the person is going multiplied by the amount of time the person is traveling or the object is traveling. So rate times time. All right, so Leo is 12 miles per hour for X hours. So Leo's distance, I'm just going to use an L for Leo, is equal to 12 times X. Okay. And then Juan started. So for part B, we're writing an equation for Juan's distance from the starting point, which is point P. If he started H hours after Leo. So we still have rate times time, but he was H hours after Leo. All right, so for Juan's distance, we know, like if Juan was starting at the same time as Leo, then we would say that Juan would be equal to 15x because they started at the same time. However, he started H hours after Leo, so we have to subtract the distance that he's behind. This distance is our 15h because he's H hours. It was H hours after Leo left that Juan took off. Okay, so then we get to part C. And we are saying, suppose that H equals 1. So we're going to say that 1 was 1 hour after Leo. 1 was an hour late. So we're going to have Leo's equation. I'll graph that in blue. I guess I should actually use y's and x's. Is equal to 12x. And then we'll do 1. His equation would be 15x minus 15 times 1. Well, 15 times 1 is just a 15. Okay, so those are the two equations that we're going to graph. And then I have the benefit of zooming in a little bit. So y-intercept for Leo is 0 plus 0. And my slope is up 12 over 1. So for Leo, we're going to go up 12, or starting at 0, we're going to go up 12 and over 1. And then we'd go up another 12, so we'd get to 24. And that would be a 2. Okay. And then hopefully I can draw a straight line. Close enough. Okay, so there's Leo's. We'll call it Leo. And then for 1, oh shoot, I don't have a y-intercept that works with my graph. Minus 15. Okay, well, so I know that at 1 hour, so maybe just because I can't graph it using the y-intercept, which would be 0, negative 15, right? Well, what would it be after 1 hour? So 1 hour would give me 15. 15 times 1 is 15. And then all of that minus 15 is 0. So I'm here. And then let's get another point. 2. That would be 15 times 2 is 30. So all of this is 30. 30 minus 15 is 15. So at 2, he's at 30 hours, 30 whatever distance. I lied. It's 15 at 2. There we go. I wrote 15. I was graphing 30. Told you I'm not feeling the best. All right. And then if I wanted to do one more, I did 3 hours. 15 times 3 is 45. 45 minus 15 is, there's my 30. So 3 hours would take me up to the 30, which I think is about there. And then like we can graph those. Something like that. Okay. Oh, and then the reason that I had this 40, this y is equal to 40 being graphed, is because the trail is only 40 miles long. So this is not a very good graph. And then it would be 45 would be my next hour at 4. So 45 would be like up here. So I don't know. They're not. My lines aren't straight. Okay. So how can you use those two graphs above to determine who finishes first? Is Leo going to stay in the lead, or did Juan finally catch up? I'm not going to answer that. I want you guys to come up with an answer, talk at your table, come up with an answer. But yeah, how can you, well, I guess how can you use the graphs? The question is, how can you use the graphs above, not who finished first? So take a minute or two, pause me, and answer the question. Come up with a how can you use the graph above. All right, so normally I would ask you as table groups to give me options, and hopefully that has happened. If not, sub. I appreciate all of you or all the work that you're doing for me right now. Can you ask some volunteers for their responses on D? Thank you. All right. And for those of you who didn't have something, you can borrow from the volunteers, or if there weren't any volunteers, then maybe like if I know that the trail was 40 miles long, whichever line crossed Leo or Juan, because they use different colors, so whoever reached that 40 first, would be my answer. Whichever line crosses y equal to 40, further on the left or on the left with a smaller x value. We'll complete the trail first. And how much of a head start must Leo have to finish the trail at the same time? So now we want to know if they're at the same time. So here's some algebra. Um, so if we want the time to be the same, it's going to be the head start that's different. So we want time to be the same. So it's going to be distance divided by rate. No, we're solving for time. That's what we're doing. Is that what we're doing? No, we want to know what the head start is. So we're going to go time. So time would equal distance divided by the rate. And if our distance is 40 for Leo would be 40 over 12. And we want that time to be equal to 40 over 15 for 1, minus, I'm just going to go the head start. All right. So you all have the benefit of using my calculators, which will work with the fractions a little bit easier than I have. My first thought was to maybe turn them into decimals. I'm like, no, that's not what I want. But 40 over 12 will simplify into a 3 and 1/3. And it's called long division. That would be equal to 40 over 15 is 2 and 2/3. All right, so why is that helpful? Well, because now I can subtract 2 and 2/3 since I want x by itself. And I still have this negative x. That's going to be equal to, well, 3 and 1/3 minus 2 and 2/3 is equal to 2/3. So, oh, that I wanted, okay. So I set it up as how much time does so one, what this tells me is that one, because then x would equal a negative 2/3 dividing by a negative one. One will be, will need to be 2/3 of an hour behind. Right, because I have my x is negative 2/3. I put the time with Juan instead of with Leo. If we had it as a plus x over here instead of that, then our 2/3 would be positive. Whatever. Um, behind Leo. Or Leo needs to be at 2/3 of an hour head start to finish at the same time. Or just don't be late, Juan. Come on, Juan. Be better. Okay, so that's just a little preview of what we're doing, um, and what we're going to be doing as we move into our examples. So, example one, we're solving a system of equation by graphing. And I ask you, what is the solution to a system of equations? Well, that is, I totally gave myself a whole lot of space, so I know I gave you guys a lot of space. But it is the point where the two lines intersect. So the solution of a system of equations is the point xy, where the lines intersect. They have to cross. Because a line, the reason why we're able to graph lines in the point x, y is the points make up all of the possible solutions for that particular equation. So we're finding, what I'm asking you is to find something, a point that's in common. So that would mean that the lines would have to intersect. Okay. Um, this right here is how you write a system of equation. You use a single left-handed curly bracket. You could technically have more than two lines written inside, but the curly bracket just extends. It gets longer for each line that you add to it. And then so that you can see that they're grouped because it like carries over. It says, I'm grouping everything from here to here as a system. Okay, so our steps. Step one, graph both of the equations. That is why we did the review yesterday that we did. Okay, so I always like to color code them. I just find that it makes things easier. So my top equation, we'll go red, not pink this time. So y-intercept is a -4. My slope is a -2/1. So from my y-intercept, I'm going to count down 2 and right 1 to get that downhill type slope. I could also count up 2 and then left 1 because that would just mean that I flipped the signs. And I'm only doing that just so that I have more points to make my line a little bit straighter. Really, you only need 2 points. But the more accurate you can draw these, the better off. Okay, all right, and then so that's top equation, bottom equation, y is equal to 1/2 x plus 6. So y-intercept is a plus 6, my slope is 1/2. Go up 1 and right 2, up 1, right 2. Or I could go down 1 and left 2, down 1 and left 2, down 1 and left 2. Okay. Step 2, find the intersecting point, which is right there. What is that point? We're going to write it. Well, so it looks like it's a -4 and +4. Okay. And then lastly, like all good algebra mathematicians, we're going to check our solution in both equations. So in my red equation, I have y is equal to a -2x minus 4. And I'm going to substitute my point, a -4 in for x and a +4 in for y. So I would get a 4 is equal to a -2 times -4 and then -4. And hopefully the right-hand side equals 4. So I do my order of operations. -2 times a -4 is a +8. 8 minus 4 is 4. Hey, they match. Smiley face. Okay. So that works for the first one. It checks. Let's try it in our second equation. We have y is equal to 1/2 x plus 6. And again, I'm putting the +4 in for the y and the -4 in for x. So we get a 4 is equal to 1/2 times -4 plus 6. Hopefully, again, this right-hand side will equal the +4 on the left. So order of operations, multiply 1/2 times -4 is a -2. -2 plus 6, that equals a +4. And again, they're the same. So if it works for both, you get check, check, then our answer is good to go. Okay? So your answer is the point, and there's a couple ways I'll accept the answer. Graphing, you could write your answer point as your answer as the ordered pair. You could also write it just as your x and y values, so that we could say that x is equal to -4 and y is equal to +4, which, I mean, you get the same information. Okay, so you have a try it, 2 of them, try it A, try it B. My lovely sub, please pause me, give the students like 5 or so minutes to attempt those problems on their own or as a table group, and then you can come back and look at the answers. So in the meantime, I'm going to just graph without talking, or maybe talk. I don't know. All right, so my top equation was a -1/2 minus 2. Okay. -2, and then my slope, I like to do with the negative with the top number, so I'm going to count down 1 and write 2. In the first equation, then we have a 3x minus 7, so -7. And then we're going to go up 3 and write 1, 1, 2, 3, write 1. And then we have the intersection. It was right there. Um, My graph it does not look 100% accurate. So maybe yours is better. I don't know, but it doesn't look like they cross at an intersection. So we're gonna just guess. I'm going to say that it's about a 1.5 on my X, because it was just a little bit over from the one. And then it would be a negative one, two, like a 2.5, a negative 2.5. And this is where you could check your answer and see if you're correct. Okay. All right. Repeat on try it B, top equation. Slope is 2 over 1, y-intercept is 10. Now here's something, 6, 7, 8, 9, 10. It's a good thing I counted. So 10 is at the top. I can't count up and right. There is no up. So if my slope here is a positive 2 over 1, isn't that the same thing as like a negative divided by a negative is still a positive? Okay, cool. So I'm going to actually count down 2 and left 1 for each of these to get my line. And then go in with the red, negative 1/4 x plus 1. So I think for this one, because I kind of know which direction I want, I'm going to make my slope. This may be controversial, but I want to go up 1 and then left 4. You can still get the same answer if you go down 1 and right, but just because I want to be accurate. 2, 3. Oh, look, my 2 points lined up. 2, 3, 4. Imagine that. See, and then if I had gone down 1 and right, like your points are going to be the same. Don't freak out. Take a deep breath. You're okay. It's all working with negatives. Okay, so there's my second equation, my second line, and find that intersecting point. It was actually on a line, so it's a -4 for my x and a +2 for the y. Okay. So example 1, and try it A and B. Example 2, just a repeat. Oh no, some of the equations are written in standard form. Well, it's a good thing you all know how to take standard form equations and write them in slope-intercept, if you so prefer. Just solve for y. How do you do that? Well, I have a 15x plus 5y equal to 25. Okay, well, so I'm going to subtract 15x from both sides, which really is just going to put it in between. I'm going to move that 25 down. So 5y is equal to a -15x. And that 25 is positive. How do I know? There's nothing in front of it. So plus 25. And then I'm going to divide everything by 5 to get y completely by itself. Everything gets divided by 5. The 15, the 25, and the 5. And that gives us the equation y is equal to a -3x plus 5. And I'm going to graph that. So plus 5, -3, down 3, 1, 2, 3, right 1, 1, 2, 3, right 1. Should be enough points. Oh, but look at that. I made a common error. My graph is not counting by ones. It's counting by two. So here's my 3, 4, 5. So, hey, I'm glad I made that mistake. I'm sure you would never have made that mistake. Okay, let's try that again. Up 5. And then from there, I'm counting down 3. So I'm not counting the lines, I'm counting The numbers 1, 2, 3, and then write 1 makes a difference. 1, 2, 3, and write 1. Okay. And we're going to draw that line. Second line is basically in slope-intercept form. My slope is the number with the x. So my slope here is a -3, and my y-intercept is a 5. Is it just because I'm sick? But I'm feeling like some deja vu. It's the exact same line. They're the same line. So what do we do? Well, the same line would give you your infinitely many solutions. Remember those from Unit 1? Many solutions, infinitely many. What did we? Yeah, they say infinitely many solutions. I'm just going to write many solutions because it's fewer words. Okay. Any guesses as to what example 2b would give us? Oh, I don't know. All right. Well, top equation is almost in slope-intercept, but it's not quite there because y needs to be by itself. So I just have to move that. I'm going to add 2x to both sides. And that gives me the equation y is equal to a positive 2x plus 6. So up 6, down to, oops, up to right 1, down to left 1, because that's a positive 2. All right, bottom equation, 4x plus 2y equal to 8. I'm going to add 4x to both sides. Gives me a 2y is equal to 4x plus 8. And then divide everything by 2. All those numbers get divided by 2. Y is equal to 2x plus 4. Now we're going to graph. So we're at the positive 4 for my y-intercept, and I'm going to go up to right 1, up to right 1, up to right 1. Well, that didn't get any closer. Down to left 1, down to left 1. I don't think those lines are ever going to cross. So there's no crossing, no intersection. Intersection, which would give you no solution. Okay. Um, so I just want you, before maybe moving on to the try it, things to think about. Like, what is the same between these two? Like looking at example A, what characteristics of the line, and by characteristics I mean slope and y-intercept, are the same? What is the same? Well, so for A, our slope here is a -3, and our y-intercept is a 5. Slope is -3, y-intercept is 5. Everything's the same. So many solutions comes from same slope, same y-intercept. Okay. Well, what about over here with our no solutions? Well, if I look up at my top equation, I have a slope that's 2 and a y-intercept or a b that's 6. And my second equation that I graphed in pink, my slope is 2 and my y-intercept is 4. So what's the same? The slope is the same. Only the slope is the same. So for no solution, they have the same slope. Same slope, different y-intercept. If I was you, and not that, I mean, we're just starting our chapter, but it's a kind of short-ish chapter. I would definitely like commit that to memory. Many solutions comes from lines that have the same slope with the same y-intercept. No solutions come from lines with same slope but different y-intercept. And then guess what? If like you're going through and changing all of your lines into slope-intercept form, why bother graphing it? Like do that check. Do they have the same slope? If you say yes, check to see if they have the same intercept. If they don't have the same slope, then yeah, you do have to graph them. Sorry. If everything is different, you have a solution. All right. So try it B. You're on your own doing the same thing. Um, I'm going to like, I'm going to do what I just suggested. I'm going to find my y-intercepts and slopes for the two equations. Oh, Sub, can you give them like 5 minutes or so? Thank you. You're the best. Although I'm not going to show all my work because that would be like annoying. I'm going to skip some steps. Same slope. Will be 1 minus 3/2. Different y-intercept. I'm not going to graph it. No, because they have the same slope. So same slope is, what was it? Just the same slope. Oh, that's no solution. No solution. And then here, oh, I have to do work for both of them. That's lame. Okay. Yeah, some space if I do. And then because I remember how to deal with fractions, if I want to get rid of them, I'm going to multiply everything by the reciprocal. And that would give me the equation. I don't know why I drew that arrow like that. But y would be equal to halves minus 3/2 x. So that looks like slope. Oops, I forgot my x there. So my slope for the top equation is a -3/2. My y-intercept is a +9/2. Slope, -3/2. There, this everything's the same. Everything's the same. So that's many solutions. All right. And then we're done. No, we're not done. There's an example 3, a story problem. Everybody's favorite. Okay. Monisha and her five friends, and five of her friends, sorry, my bad, want to attend a concert. They are trying to decide whether to buy tickets online in advance or at the ticket booth on the day of the concert. They have $400 total. $400 total. Okay. And then we get into our two equations. Online, $62 each. That's going to be one equation. So I'm going to do online is my top first equation, and cost is equal to price times the number of tickets. So C is for cost. I guess I'll use a T. T for number of tickets as opposed to P for people. Okay. Oh, and I didn't read the rest of it. And buying it online, there's a one-time service fee of 18. $18 plus 18. Okay. Buying the tickets at the door is just $67. So at the door. Cost is equal to 67 times the number of tickets. Okay. We want to know, when will the cost be the same? So yes, I know, like, I could create a chart. Where did my equation? Where did everything go? That seems kind of silly. Like, I have this nice big graph here. So we're gonna graph them. We have cost. Cost is like our Y. Cost up here is our Y. And the number of tickets is our X. So I can just graph them. So I'm starting at 18. 1, 2, 3, 1, 2, 4. Oh, that's not even counting by 10. Um, it doesn't change, does it? It's still only four lines to get to 50. The 12.5. That just stinks. Is 1. So it's just above. And then I have to count up 62. Wow, these lines are something. Oh, so one line is 12.5. Two lines would be 25. All right, so it's like, yeah, it's somewhere in between. These are not going to be perfect graphs, because I gave you a really wonky scale factor to work with. I apologize. Maybe a table would be better. Um, Also, I should not be doing math this late when I'm sick. Okay. So that's like at 18 plus 62 would be 78. 75, so it's basically there, and it'd be over 1. So we're like here. And I'm just going to wing it. And then 67, that's nice because it's going to be like at 0. And then we go to 67, and 1. And then 2 tickets would be 150, no, 134. which is like here. So I don't know, there's something like that. As you can see, sometimes graphing is not the best. So after that short break, my calculations, besides from my graphs being ridiculously off, because it says that they should be crossing like somewhere over here. So I'm going to say that this one is the one that's off. And that one's the one kind of off, but not. This is like here. I don't know. And then like that. So they're going to cross exactly at, woo, a 3.6. And we're going to say it's about 200 because I don't want to guess. $200. So what number of tickets will the cost be exactly the same? Cost will be exactly the same. Look at me writing my sentence. Cost will be the same if 3.6 tickets are purchased, are bought. There's my answer. It doesn't matter how they bought them, as long as they buy 3.6. Okay, so which way will it cost less for all six to attend? Well, which one has the lower slope? I think that's online. But let's just check. So online for six people, it was 62. I'm just going to say this is an O. 62 times 6 plus 18. And handy dandy calculator, 62 times 6 plus 18 is equal to $390 for all six tickets. And at the door is 67 times 6. No service fee involved, so just a 67 times 6. Yep, 402. So online is cheaper. Buying buying the tickets online is cheaper. Buying the six tickets online is cheaper. Okay. All right, you get to do the try it down here. Two of the friends realize they cannot attend. Which method is the cheaper option? So instead of doing six, you have four. You're only buying four tickets. Wow, I'm writing in a highlighter. Isn't that fun? T equals 4. Which one is cheaper? Pause me. Please, please, please. And then, well, yeah. So online would be 62 times 4 plus 18. Should be the cheaper option. I wrote 64. I meant 62. It's 266. Door. 268. Um, just wanted to double check. Which method is cheaper? Online. Online is still cheaper. And then difference means subtraction. So 390 minus 266. The final answer. $124 is the difference.